Hey everybody, I hope you're doing well. We're going to continue working on a problem that I left you with in the last video. And I am hopefully 100% sure that it was this. Acid, and then we're going to say hydroxide and some heat here. Again, not decarboxylate level heat, but some. Now, what we're going to work on is the steps here. So let's start with cyclohexanone up there. The LDA, lithium diisopropyl amide, is going to pull the proton off of the cyclohexanone, form the enolate. Nothing new here that we haven't seen before. Enolate will attack the beta carbon of the alpha beta unsaturated carbonyl, putting us here. Now, as always, we need to take a moment and make sure that the structure we have is right. This one is. We add a little bit of acid, and we get this. And we could walk away happy with that molecule. I mean, really, it's not a bad molecule itself. But I am adding the extra wrinkle of the heat and the base. This is where it gets weird. So let's make it weird. So again, we are here, just rewriting it for the new page. And the reason this works is because we've got a proton there. Hydroxide will pull that off. Probably not the best base for the job, but you do have other sites that would make this inconvenient. So, pull that proton off and make the enolate, which puts you here. With this product. All right, reform the enolate. The pi bond attacks the carbonyl, opening up the carbon-oxygen pi bond, which puts us here. As our intermediate. All right, add some acid to finish it off. And what we have done is make this. So the steps here are, for this entire process, are 1, enolate. 2, conjugate addition. 3, protonate. 2, tautomerize. 4, enolate, which then in turn does a Claisian condensation. Now, if you are seriously out there asking yourself, why do I care about this? Take a good long look at that product in yellow. Take a good long look at that. This is the method that is used for the creation of synthetic steroids. Obviously, there's more to it than this, But this is the primary method of producing completely synthetically made steroidal type compounds. All right, so that's really it for the new material. I do want to work on a couple problems, though, to maybe help you sort some of this out. So let's start. All right. So let's say we take cyclopentanone and we react it with, I'm sorry, let me change that starting material there, put a pi bond there, that alpha-beta unsaturated cyclohexanone, and we're going to react it with a Grignard reagent. Okay? What do you think the product will be? I'll pause here so you can give a stab at it yourself and see. Okay, so the product would be this. Remember, Grignards and alkylithiums as well as sodium borohydride and lithium aluminum hydride and hydroxide and alkoxide, all of these favor a direct or 1,2 addition. In case you're wondering where the 1 and the 2 come from, it's not nomenclature 1,2. I know that's irritating. It's like this, 1, 2. All right? So let's take a look at this one. Here's what I want you to do. Let me see. I want this one. That enolate followed by benzyl bromide followed by some acid. All right, give this one a spin. I'll be back in a sec. Okay, what I'm going to do here is I'm going to give you the product, and then I want you to show the mechanism for it. So here is your product. There's your product. What I would like you to do is show me the mechanism for that. I got one more I want you to work on. I'm not going to tell you what that is. This is just practice for you. I've got one more I want you to work on. This is it. Using only acetophenone as your only carbon choice, I want you to show me how to make this. All right, using only acetophenone, make this. All right, folks, you think you got it? I hope you do. Let's take a look. Remember, we start with only acetophenone as our carbon source. So the first thing we're going to do is use a base and make the enolate out of this. How should we know to do that, Dr. Weigel? What the hell have we been doing through this entire chapter, people? You're mean. You have no idea. So the enolate attacks a ketone, like so, and you get this. It's amazing how quickly I run out of space over here, isn't it? All right, add some proton just to turn that alkoxide into an alcohol. Sorry, folks, that was my mistake. Let's fix that. In case you're wondering why I show you wrong answers and then fix them myself, partially it's to show you that I'm human, and partially because this program, I can't edit the videos. So what you see is what you get. All right, so your product here would look like this. Now, this is a Claisian addition. You can lose the hydroxide and generate this. All right, there's your alpha beta unsaturated carbonyl. Here comes another enolate. Conjugate addition. And what you wind up with is this. So this is Claisian addition, Claisian condensation, alpha beta unsaturated, bleh. Let's start that from the top because I've suddenly lost the ability to talk. This is a Claisian addition, Claisian condensation. This step over here is a conjugate addition. And then finally, you add enough acid that you get to the final product. All right, ladies and gentlemen, I think that's it for this chapter. So I'm going to stop here. And tomorrow, when I record a few more of these, we're going to be talking about aromaticity, and after that, aromatic reactions. And then, ladies and gentlemen, we are done.